Good afternoon, everyone. Landslides have always existed on our planet. Generally, it is classified as a mass movement, a rock failure, or a soil down of the slope land. While the landslides have naturally occurred as an environmental hazard, but recently it has been increased because of the human activities. So here is the solution: landslide susceptibility mapping using association rule mining-based Apriori Algorithm and multiple clustering algorithms. So I am Chandi Mandakshi, the presenter of this research, and my internal supervisor, Dr. BTGS Kumara from Department of Computing and Information Systems, Sabaragamu University of Sri Lanka. So here it is the content of my presentation. Haphazard development activities on the mountain slopes and inadequate attention to the construction aspects have led to increase the landslide and consequently sustaining damages to the lives and the infrastructure. There are two major causes which affect to the landslide: natural causes and the human activities. And there are some factors affecting to the landslide, and here I have mentioned a few of them. As a significance of my research, landslide transpired when a part of the natural slope cannot bear its weight. Therefore, landslide happens when the stability of the slope changes from stable to unstable states. And it is one of the recurrent geological hazards during the rainy season. The study area that I have concerned, nearly 3,275 square kilometer area spread over Apriori district, and seems to be highly prone to the landsliding of 2,178 square kilometers, and nearly 19 deaths have reported. The accurate prediction of the landslide for the ground movement is very important. Therefore, most landslide or the potential failures could be predicted relatively and accurately if a proper investigation were performed in time. In here, the study area has a zonation map of Ratnapura district. As an objective of my research, to present in a multiple clustering approach, which is relies on the K-mean and EL clustering to landslide risk assessment, and conduct a comparative analysis between two clustering approaches. Other than that, to propose best routes to determine the expected landslide location in the future, which taken from the landslide data using association rule mining-based Apriori algorithm. This is the methodology of my research. It contains three major steps and two major parts. First step, data collection and preparation, built-in landslide prediction models, and model evaluation and comparison. And also there are two major parts. The first part based on the clustering model to landslide risk evaluation, and second part based on the association rule analysis for landslide causative factor analysis and pattern recognition. Here is the data collection and preparation, and I have mentioned the 10 major contributed factors as a data usage and the sources where the data have been collected, and also development environment, the softwares and the tools that I have executed this research methodology. Though we have a large amount of data, but we don't have useful information in each and every field. Therefore, data pre-processing is required. As a first step, raw data cleaning, which concerns the discovery, elimination and corrections of the variance in the data set, and identify the outliers and observational method in the data set that identify the inconsistencies within the majority of the data. And as an important step, normalization, which is a scaling method to arranging the data to discover the novel range of data from existing data range. And the prediction model, building the landslide prediction model contains two steps: data clustering. Clustering concerns with the clusters have a great similarity by comparing one another in the same cluster, but dissimilar the objects in the different clusters. In here, I have selected widely used clustering algorithm, K-mean and expectation maximization. K-mean is a clustering technique beginning with the description of the basic algorithm, and choosing the K initial is the first step as a user-specified parameter. And the second step is to specify each point of closest centroid and every collection of points assigned to the centroid in a cluster. And these two steps are repeated and updated until there is no point change in the cluster. And the expectation maximization, which is an iteration approach to discover the maximum likelihood and the minimum likelihood estimates of the parameters in statistical model. And it contains two steps: expectation step and maximization step. In each step, it is produce the function for expectation of the log likelihood estimated using the contemporary estimate for the parameters, and also the maximization step, which estimate the parameters for maximizing the expected log likelihood found in the above expectation step. And figure 2, I have provided the process of clustering. The other prediction model is based on the association rule mining for landslide monitoring and pre-warning. Therefore, association rule mining used to find the connection between the different data items in the database. And also, I have selected Apriori Algorithm To discover the frequent association, the reason behind selecting this a priori algorithm is which is frustrated, simple and leads to best performance by reducing the size of the candidate set. And figure 3, I have provided process of association rule mining. Let's conclude the results and the discussion. The content was classified into 2 classes based on the areas where the landslide occurred in future and did not occur in future or was not expected to occur in the future. Other than that, I have provided the casual factors based on the 10 major contributory factors that affect to the landslide and their categorical classes based on the data distribution. And also, the most important parameters to the landslide influencing have been recognized and categorized as rainfall, slope, land use, soil cover, bedrock shearage intensity, aspects and the elevation. And also, landslide susceptibility assessment was done by establishing the spatial relationship between the landslide influencing parameters and their category classes. While applying the clustering algorithm as a first step, K is specified as a value of 3. Therefore, the content was classified into based on 3 classes: high risk, moderate risk, and the low risk category. And as a prerequisite, we have to select the attributes where the major contributory factors. Therefore, I have selected Infograin attribute evaluation algorithm, which is available as a subclass of Vector data mining tool to score in the features. Then I have found 4 positive factors as attributes for clustering approach. These are the experimental results while applying K-mean clustering and expectation maximization clustering. Then I have determined the highest accuracy was obtained by K-mean clustering and highest speed was obtained by EM clustering algorithm. And here is the graphical representation of the accuracy comparison between the 2 clustering algorithms. Therefore, the accuracy of the correctly classified K-mean was 91.132% and 83.485 accuracy was obtained by EM clustering algorithm respectively. And also the K-mean clustering algorithm, the time taken to build the model was 1.58 seconds and EM clustering 0.66 seconds. Therefore, we can determine that the highest degree and the EM clustering algorithm has a best degree to fit for the landslide risk evaluation. And while applying the association rule mining, 10 best rules found elaborate with the Apriori algorithm and their performance were measured comparing by based on the support, confidence and the lift value. And let's see the summary of the presentation. In order to compare to analysis between K-mean and EM clustering, the accuracy was compared by using the clustering results and the speed. And also EM clustering method shows 84% results with the highest speed and the highest accuracy over 92% was obtained by the K-mean algorithm, but it was more time consuming than EM clustering. And it has been demonstrated that EM-based landslide risk evaluation model can help to implement the guide to reduce the disruptive impact of natural disasters in the surrounding communities. And these are the limitations, recommendations, and the future work. As a limitation, the data collection constraint, and it takes more time to collect the data. And as a recommendation, I recommend to FP growth for pattern recognition for landslide prediction model instead of a priori algorithm. And I recommend to conduct the programs in hilly and mountain areas about the control of the runoff and the erosion, which can be extremely beneficial to effect on control the natural hazard. And as a future work, I intend to concentrate on deep learning approaches, which is a broader family of machine learning methods, and also develop a landslide warning system may be induced by the rainfall. And these are the references that I have written. And this is the acknowledgement to say thank you for all the government department for providing me the data and their contribution until the end of the research. And here is the end of my presentation. Thank you for your valuable time and listening me patiently. Thank you.
Thank you, Ms. Chandima. So I would like to open this for question and answer session. So do you have any questions? At least one.
features you have used? The features, that is factors that affect landslides?
Rainfall is a climate variable, and the elevation, slope angle and slope aspect, intensity, and the land use based on the main category and subcategory, and also the soil type, and bedrock geology, bedrock geology, that is the category of the rock type. Likewise, 10 major contributory factors I have found. Accuracy, comparison. Yes. Not presented. And mainly based on the accuracy, based on the clustering results and the speed.
Any other questions? I would like to ask one question. So how big is your data set?
For this purpose, I have selected 10 major factors and more than 300 landslide location, and also non-landslide location 200, all the 500 data locations. Thank you.
Thank you very much.
Thank you.